Hi guys, we're going to take a look at question 6 of paper 1 of the 2016 exam. Okay, so we want to differentiate the function 2x plus 4 squared from first principles with respect to x. Okay, well, what does it mean to differentiate with respect to first principles? First principles. Well, this is just using our definition of the derivative, which is f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x over h. So it's like the instantaneous slope. So if you have a curve like this, or let's just say like this, well then f of x plus h, let's say this is f of x, okay? And this is h. Well then this would be f of x plus h, okay? And so the slope of the function at this point is approximately the rise over the run. This is approximately the slope of the function at this point. Okay, and as h gets smaller and smaller, this approximation gets better and better. So as h approaches 0, it becomes exactly the derivative. That's literally how we define the derivative. So using this idea, we want to differentiate 2x plus 4 squared. Okay, well, we have the limit as h goes to 0 of f of x plus h. Well, what is f of x plus h? Well, f of x plus h is just 2 by x plus h plus 4 squared, and then minus f of x, which is just 2x plus 4 squared. And then all of this divided by h. Okay, well now let's just multiply this out. So we have 2x plus 2h plus 4 squared minus 2x plus 4 squared, which is just 4x squared plus 16x plus 16. Okay, and this all over h. So the limit of this is h goes to 0. Okay, well 2x plus 2h plus 4 squared will be 4x squared plus 8x h plus 16x plus 4h squared plus 16h plus 16, and then minus these remaining terms, 4x squared plus 16x plus 16. Okay, well, we'll see that a lot of these terms are going to cancel. The 4x squared is going to cancel. The 16x is going to cancel. Sorry, this is 16x. And then the 16 is going to cancel. And so it's going to leave us with 8xh plus 4h squared plus 16h over h. So the limit as h goes to 0 of this. Okay, and then the problem with this, the problem we can't just, throw in h equals 0, is that we get 0 on the top and 0 on the bottom. Okay, but because we have h is a common factor at the top and it's on the bottom, the h will just cancel. So, well, one of these h's will cancel, and then this will cancel. So we'll get the limit as h goes to 0 of 8x plus 4h plus 16. And as h goes to 0, well, 8x will remain 8x, 4h will go to 0, and 16 will remain 16. So it'll just be 8x plus 16. And so that's the derivative according to first principles. Okay, and well, that's just our answer. But we might want to calculate the derivative the standard way, just to make sure that we got it right. Well, the derivative of 2x plus 4 squared, well, we just bring down the power. So that's 2 by 2x plus 4. And then we multiply that by the derivative of the inside term of 2x plus 4, because we're using the chain rule. And the derivative of 2x plus 4 is just 2. So it's just 4 by 2x plus 4, and that's just 8x, plus 16, which is what we got. So we are happy with that. Now on to part B. If y equals x sine of 1 over x, find dy dx. So we just want to find the derivative of x sine 1 over x. So y equals x sine 1 over x. And find dy dx. Okay. Well, first of all, we've got a product of two functions. We've got x, and then we've got sine 1 over x. So straight away, we're going to look at the product rule. So if y equals uv, then dy dx equals u times dv dx plus v times du dx. So the function times the derivative of the second function plus the second function times the derivative of the first function. Okay, so u in this case equals x, and v equals sine of 1 over x. So dy dx equals u, which is x, times the derivative of sine of 1 over x. So the derivative of sine 1 over x with respect to x, plus v, which is sine 1 over x, times the derivative of u, which the derivative of x is just 1. Okay, so all of this is fine, except we don't really know what's the derivative of, we don't really know what this term is. Okay, so let's try and calculate this term, because the rest of it is fine. If we calculate this term, then we'll have done the question. So what is the derivative of sine by 1 over x? Okay, well, this is a function within a function, so we immediately think of the chain rule. So if we've got y equals u of v, then dy dx is equal to du dv times dv dx. Okay. Sorry. That's a dv dx, not dv dy. Okay. So we've got a function u. So we've got a function within a function. So our u, u equals sine of v, and v equals 1 over x. Okay, so we want to find the derivative of u with respect to v. So du dv is the derivative of sine of v, which is just cosine of v. And then the derivative of v with respect to x is just, so 1 over x is x to the minus 1, okay? And we have our rule, x to the n, so the derivative of x to the n is n times x to the n minus 1. So for x minus 1, that becomes minus 1 times x to the minus 1 minus 1, which is minus 2. So that's the same as minus 1 over x squared. Okay, so then we get, let's just write up here. Actually, I want to draw this kind of separately. So d of sine 1 over x over dx is du dv cosine v, and where v is just 1 over x, so let's just put that in, 1 over x, times dv dx, which is just minus 1 over x squared. Okay, and so now we'll go back to dy dx, so dy dx, and that's our expression in green here, our expression in red here. So we're going to use this formula, this expression that we have for dy dx, because we know all the values here. So dy dx equals x times this derivative here, which we've just found. So that's x times cosine 1 over x times minus 1 over x squared. And then plus sine of 1 over x. Okay, and so in this term here, this first term, this x here is going to cancel with one of the x's on this denominator here. So we're just going to get dy dx equals minus 1 over x by cosine 1 over x plus sine of 1 over x. And that's our answer for the derivative of y. Now on to part 3. Find the slope of the tangent to the curve y equals x sine 1 over x when x equals 4 over pi. Give your answer correct to 2 decimal places. Okay, so we're looking for the slope of the tangent to the curve well, this is just the definition. This is just the definition of the derivative of the curve, because the derivative is just the rate of change. So it's the slope of the curve. So if we have a curve here, then the derivative here is just the slope, the instantaneous slope, which is this, which is also the tangent to the curve. Okay? So we want to find the slope of the tangent to the curve, y equals sine inverse over x. Translation, find derivative of y equals x sine 1 over x when x equals pi over 4. Sorry, when x equals 4 over pi. Well, we've already just found what the derivative of this. We found an expression for the derivative. And we want to sub in 4 over pi wherever we see x. So y prime of 4, which is just dy dx evaluated at 4, is just minus 1 over x, which is 4 over pi, times cosine by 1 over 4 over pi, plus sine 1 over 4 over pi. And now this is just, well, this just flips around. It just becomes minus pi over 4 times cosine pi over 4. And cosine of pi over 4 is just root 2 over 2. So let's just say cosine pi over 4 plus, again, sine pi over 4. And then if you just put that into your calculator, we just get minus pi over 4 times square root 2 over 2 plus square root 2 over 2. Okay, and then if we put this into our calculator, 0.1517, or to the nearest decimal, or to the nearest 2 decimal places, 0.15.